And this question it is given that two rods of same length and same diameter are drawn from equal masses and same quantity of heat is supplied to the two rods. Find the ratio of expansion if specific heat of material is 2 by 3 and that of coefficient of linear expansion is 1 is to 2. So specific heat of 1 is to specific heat of 2 is given as nothing but 2 is to 3, and the coefficient of linear expansion lambda alpha 1 by alpha 2 is given as nothing but 1 by 2, or ratio we can take it as 1 is to 2. So RM is to find the ratio of expansion. They might be considering the volume expansion. So RM is to find out the expansion in first one is to expansion in second one. So we know the equation for this expansion or change in volume is equal to initial volume into we can take it as the value of 3 times of alpha or gamma into delta T, or we can write this as 3 times of alpha into delta T. So we can say that basically this change in volume is depends upon the value of initial volume. This 3 is a constant and the value of coefficient of a linear expansion and delta T. And in this question it is given that same heat is supplied, so we can find out what about the relation between heat energy supplied and change in temperature. So from that equation Q is equal to ms delta T. We can write this Q is directly proportional to the value of or Q is equal to, we can take it as m into s into delta T. So we can write this Q divided by m into s will be the value of delta T. Or you can write in this question it is given that same amount of Q is supplied, so Q is a constant and mass is also constant, but specific capacity is different, so we can write delta T is inversely proportional to specific capacity. So from the first equation or from this equation we can say that change in volume is directly proportional to the value of alpha and change in temperature, and from this equation we can say that this change in temperature is inversely proportional to specific heat, so we can write this change in volume is directly proportional to coefficient of linear expansion alpha, and it is inversely proportional to the value of specific heat. So we can write change in volume in first case divided by change in volume in second case will be equal to alpha in first case divided by alpha in second case into specific capacity in second case by specific capacity in first case. Now in question the value of alpha 1 by alpha 2 is given as nothing but 1 divided by 2, and s2 divided by s1 is given as nothing but 3 by 2. So we can put this value, so it's going to be 3 divided by 4.